So here's the problem that you had to do on your own. So let's go ahead and draw this little area, well, just a little model here, the box of this. And so I wrote my x term over here, and then what I was multiplying by, 6x squared plus 4 along the top. And then I'm going to multiply these things together. 7x squared times x makes 7x cubed. And then x times 4 makes 4x. Therefore, my solution is 7x cubed plus 4x. And like I said, you can get that same thing simply by distributing the x. X times 7x squared is 7x cubed, and x times 4 is plus 4x. There's many ways of thinking about it. So hopefully you got 7x cubed plus 4x. If you didn't, make sure you ask and seek out that support. Otherwise, let's move on to our next example, where we're multiplying two binomials. And when I say two binomials, right, we got to remember, of course, what a binomial is. That's x plus 4 times x minus 2, right? A binomial has two terms, right? Two terms. And both of these have two terms, and so they are both binomials that we are multiplying together. Now, let's apply that model, that area model that we had just learned with the other one. Now, because we have two terms, along the left-hand side, we're going to have two different things to multiply here. And along the top, we're also going to have two. Now, notice how that creates a rectangle. In the previous example, a square. In the previous example, we had one long rectangle where the x was multiplying kind of through. When we're multiplying binomials, we end up with more things to multiply together. So let's fill in all the boxes here. X times x makes x squared. And x times negative 2 makes negative 2x. And 4 times x makes 4x. And 4 times negative 2 makes negative 8. And like I said in the previous one, what's in the boxes, that's our solution. X squared minus 2x plus 4x minus 8. Therefore, this is x squared. And then remember, these have the same terms, so we need to combine them. Minus 8. So again, we can use this area model to kind of represent the variables that we are multiplying together. And doing so gives us kind of a nice organized way to see all of those possibilities. Let's do another example, and this time I want to show you both the area model and, again, just distribution. So let's start with the area model. We're going to do x minus 4 along the side here, and we're going to do 3x plus 2 along the top, and that's going to give me 4 boxes to fill. Kind of like a times table. Do you remember doing times tables? Anyway, x times 3x is 3x squared. X times 2 is 2x. Negative 4 times 3 is negative 12x. And negative 4 times 2 is negative 8. So my solution is 3x squared minus 12x plus 2x minus 8. And then these two have the same term, so they need to be combined. And there's my solution. Of course, that's a 3x squared. I just ruined it. Knowing that, let's take a look at this same problem, but let's do it a different way. Instead of setting up the box, what I'm going to do is distribute. But you'll remember that distributing means I take this thing and I multiply it over. Well, I have two terms here. And I can't just multiply x, and so what I have to, when I distribute this, I'm kind of distributing this whole thing. This whole x minus 4 is multiplying the 3x, and this whole x minus 4 is multiplying the 2. So let's write that down because it sounds kind of confusing. I'm going to take x minus 4, and I'm going to multiply it by 3x. I get 3x times x minus 4. Right? See what I did? I took this whole term, and I multiplied it by 3x. And then I'm going to take this whole term, and I'm going to multiply it by 2 plus 2 times x minus 4. Again, you see how that happened? I took the whole term x minus 4, and I distributed it to everything inside the binomial. So then I distribute again, 3x squared minus 12x. Notice how the 3x squared is that one there. The minus 12x is that one there. Plus 2x minus 8. There's the 2x. There's the minus 8. And then I combine like terms, and I get the same solution. Now, the fun thing about that is it actually doesn't matter which one I distribute to which. I could have easily, just as easily have done this in the reverse direction and done x, that x right there, times 3x plus 2, and then negative 4, also times 3x plus 2. And notice I'll get the same solution. Notice how we just switched it, right? This time I'm distributing the 3x plus 2 to each of these. 3x squared plus 2x minus 12x minus 8. I get the same 4 numbers no matter how I multiply it. Here's the moral of the story. Every term in one polynomial multiplies every term in the other. It doesn't matter the size of your polynomial. Every term in one polynomial multiplies every term in the other. Notice how the x multiplied both terms. Notice how the negative 4 multiplied both terms. Notice how the 3x multiplied both terms. Notice how the 2 multiplied both terms. So it doesn't matter how we organize it. What matters is that every term in one polynomial multiplies every term in the other. All right, I got an example that I would like you to complete back on your notes. This video, that's the end of this video. Go ahead and check your next video for the solution to that problem.